All right, so today we're going to be looking at an idea that I'm going to call negative work. Not just me. I'm not the great one that came up with that. Negative work. So essentially we could have force and we had negative force. We would say that the force we applied, we typically would call that your positive force. And then any forces opposing that, whether it's another person or friction or air resistance, we call those negative forces. Well, if we have friction, so let's say, let's even jump right into the question there. So last time we figured out that work is equal to force times the distance times the cosine of the angle the force is being applied at. All right, so just basic equation we're using there. So there at the bottom, we have this question. You use 100 newtons of force to push a crate with a weight of 20 newtons 10 meters, while kinetic friction exerts a force of 30 newtons. What is the total work done on the crate? All right, so just kind of looking at the scenario we're looking at. So we've got a crate. It's on the ground. And it actually made it kind of easy for us. So first things first, let's figure out. So I apply, or somebody's applying a force of 100 newtons. Let's say we're going to push it that way. So the force applied is 100 newtons, all right? To push a crate with a weight of 20 newtons, weight is force of gravity, so I know I've got a force of gravity of 20 newtons, or if I want to get real technical, it's downward. That force is downward, negative 20 newtons. And we're going to move this crate 10 meters. All right, so the distance we're moving it is 10 meters, while kinetic friction exerts a force of 30 newtons. So I could actually call that force of gravity. All right, so we've got kinetic friction. So we've got a force of friction. They did the hard work for us. They figured out that it is 30 newtons. Or, since it's opposite direction, negative 30 newtons. However it is you want to work with it. All right, so they want to know what's the total work or the net work done on the crate. All right, so a couple things to look at here is, so we've got a force of gravity. That also means we've got a normal force that's equal to just the opposite of it. So if we've got negative 20 newtons coming down, that means that the floor is exerting a force of positive 20 newtons upward. So we could go through, and right away we know that the crate itself is moving, in this case, in the way that I have the diagram written, it's moving to the left. It's not moving up or down. So right off the bat, if it's not moving up or down, we have no distance in the up or down direction, in the y direction, if you will. So that means that the work that gravity is doing is 0, and the work that the normal force is doing is 0 as well. Oh, and joules, 0 joules, okay? So because it's not moving in that direction, all right? So now I have a force applied, which means we can look at the work that's being applied to the box, and we can also look at the work that friction is doing to the box. And figuring this out is going to be pretty basic. So we've got the force applied, work equals force times distance. In this case, our forces are being applied, in the same direction it's moving. So they're being applied at a 0 degree angle. Cosine of 0 is 1. So we don't even need to worry about that. Thank you. All right, so the work applied is going to be equal to the force applied times the distance it moves. So in this case, it's 100 newtons. And it moved 10 meters. And so that means the work applied was 1,000 joules of work. Okay, not even going to dig out a calculator. 100 times 10, that's 1,000. The friction force, though, is equal to the force of friction times distance. In this case, the force of friction was negative 30 newtons. And that negative 30 newtons was still applied across that 10 meter distance. That gives us a work that the force did of negative 300 joules. All right. We're applying 1,000 joules of work to the crate. Friction is applying a force of 300, or sorry, negative 300 joules to it. So really to find the total work, or once again, another way to think of it is the net work, is we're going to just add these two things together. So we've got 1,000 joules plus a negative 300 joules. And so I've got 1,000 plus a negative 300, or 1,000 minus 300. That should give me 700 joules of work total being done to move the crate 10 meters. So essentially, it's just we're just adding these two things up. It's pretty basic, essentially. So then we can even add these things to our diagrams if we really want it to get a little bit messy. So I've got the work applied equals 1,000 joules, because that's easy to read. We've got the work that friction's doing. I'm not even going to give it its own arrow. Negative 300 joules. And then there's a couple things that we could list. We could say that the total work, let's just sit there. You know, if we're trying to keep everything around our diagram there, that's the answer it's looking for. Keep in mind, there's some times where they're going to make you find the force of friction. So if we have the normal force and they gave us that what was I going to say? The coefficient of friction is equal to 1.5. We could find that the force of friction is equal to the coefficient of friction 1.5 times the normal force, 20 newtons. And if I did my math right, I think that is 30 newtons. And once again, we just pop the negative because it's in the opposite direction. So if they have the coefficient of friction there, I can figure out what the force of friction is. You know, all that stuff we learned about forces, they still apply when we're talking about work, since work just is, it's an application of force. It's how much force is applied over a certain area. And that becomes really important with what we're going to talk about when we talk about kinetic energy and gravitational potential energy. Work is just a transfer of energy. And this is figuring out what's our net transfer of energy. This is how much energy we applied to the crate to move it. This is the amount of energy friction applied to it, or took away from us, if you will. And this was the total change in energy. This is how much we gave it. That's really all negative work is. Good luck with the practice problems.